How to remember trigonometric formulas. There's a lot of formulas in trigonometry, such as sum and difference formulas, sine alpha plus beta, sine alpha minus beta, cosine alpha plus beta, cosine alpha minus beta. Double angle formulas, sine 2 alpha, cosine 2 alpha, tangent 2 alpha. Half angle formulas, sine half theta, cosine half theta, tangent half theta. Product to sum or difference formulas, sine alpha cosine beta, cosine alpha sine beta, sine alpha sine beta, cosine alpha cosine beta. Sum or difference to product formulas, sine alpha plus sine beta, sine alpha minus sine beta, cosine alpha plus cosine beta, cosine alpha minus cosine beta. I learned trigonometry when I was a kid at high school. That was 65 years ago. But now I can still recall those identities less than 30 seconds without any mistakes. How could I do that? I share my experience with you in this clip. How to remember trigonometric formulas? 2 steps. First, remember 2 key identities formally. Second, deduce the other ones I want in less than 30 seconds. First step, remember 2 key identities. I notice sum and difference formulas can deduce other identities. They are sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Sine alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. Cosine alpha plus beta equals cosine alpha cosine beta plus minus sine alpha sine beta. Cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. These 4 identities is the one I use to deduce others. Let's look at these 4 identities more closely. Sine alpha minus beta differs from sine alpha plus beta only in sign. Cosine alpha minus beta differs cosine alpha plus beta also only in sign. So if I remember these 2 key identities formally, just by changing sign, I can get another 2. Okay, so these 2 are the key identities we have to remember. How? We look at sign. On the right, we see the sign. They are same sign. We see the product. They are different function. Sine, cosine, cosine, sine. So I remember it is sine, same sign. How about the product? They are different function. Sine, same sign. Cosine is different. How different? Sine is different. Product is different from here. It's same function. Cosine, cosine, sine, sine. Okay, let's summarize it. We use the sum and difference formulas to deduce others. They have 4, but 2 is the key. Sine, same sign. Sine alpha plus beta, same sign, is sine alpha cosine beta plus same sign. Different function. Sine alpha cosine beta, cosine alpha sine beta. This is how I remember it. Sine, same sign. Cosine is different. Cosine alpha plus beta equal different sign and same function. Minus plus cosine, cosine, sine, sine. And then we change the sign, we get sine alpha minus beta. We change the sign, we get cosine alpha minus beta. These are the four identities which are used to deduce others. Before I do that, I have to find tangent alpha plus beta. We know tangent equals sine over cosine. And sine, same sign. Cosine, different sign, but same function. Unfortunately, this expression is not what I want. I want to express tangent alpha plus beta in terms tangent alpha and tangent beta. How can I do this? I divided cosine alpha, cosine beta on both sides. We look at this. Cosine beta cancel out. Sine alpha, tangent alpha. Plus cosine alpha cancel out. Sine beta, tangent beta. Cosine alpha, cosine beta, 1. Minus sine alpha, tangent alpha. Sine beta, cosine beta, tangent beta. That's it. That's it. So tangent alpha plus beta equals tangent alpha plus tangent beta over 1 minus tangent alpha, tangent beta. How about tangent alpha minus beta? Let me rewrite alpha minus beta into alpha plus minus beta. In writing this way, here is the sum of two angles. So I can use this formula, replace tangent beta by tangent minus beta. So I get tangent alpha, tangent minus beta. 1 minus tangent alpha, tangent minus beta. And we know tangent minus beta equal minus tangent beta. We take this minus up, we get tangent alpha minus tangent beta. 1 plus tangent alpha, tangent beta. Actually, you see, if you change the sign in tangent alpha plus beta, you change this to minus, you change this to minus, you change this plus, instantly you get tangent alpha minus beta. Now we deduce others. First is double angle formulas. We have these two in our mind. We want to find sine 2 alpha, cosine 2 alpha, tangent 2 alpha. We set beta equal to alpha. So sine alpha plus beta equals sine alpha plus alpha. Sine 2 alpha equals sine alpha cosine alpha plus cosine alpha sine alpha 2 sine alpha cosine alpha. Cosine alpha plus beta, we set beta equal to alpha, you get cosine alpha plus alpha, cosine 2 alpha equals cosine alpha, cosine squared alpha minus sine alpha, sine squared alpha. As we know, sine squared alpha plus cosine squared equal to 1, the identity. And we replace cosine squared alpha by 1 minus cosine squared alpha. We replace this one. We get cosine 2 alpha equal 2 cosine squared alpha minus 1. If one replace cosine squared alpha by 1 minus cosine squared alpha, we get cosine 2 alpha equal to 1 minus 2 sine squared alpha. How about tangent 2 alpha? We set beta equal to alpha. We get this tangent alpha, tangent alpha. So tangent 2 alpha equal to tangent alpha, 1 minus tangent alpha equal to 2 tangent alpha, 1 minus tangent squared alpha. Next, half angle formula. We know half angle is the reverse of double angle. So we approach starting from double angle and then try to get half angle. Cosine set beta equal to alpha. So we know that cosine 2 alpha equal to cosine squared alpha minus sine squared alpha. Also is equal to 2 cosine squared alpha minus 1. Also equal to 1 minus 2 sine squared alpha. Now, this is a double angle. We want to find a half angle. What we do, we rewrite this formula. 2 sine squared alpha equal to 1 minus cosine 2 alpha. 2 cosine squared alpha equal to 1 plus cosine 2 alpha. Now, we want to go back. We set 2 alpha equal to theta. Then alpha equal to half theta. We rewrite this one in terms of theta. We get 2 sine squared half theta equal to 1 minus cosine theta. This is half angle. 2 cosine squared half theta equals 1 plus cosine theta. So from these two, I get sine half theta equal to 1 minus cosine theta over 2 square root. Cosine half theta equal to 1 plus cosine theta minus 2 square root. And tangent half theta equal to sine half theta divided by cosine half theta. We divide this by this. We get 1 minus cosine theta, 1 plus cosine theta. Many people, including me, don't like square root. So we do some operation, try to get rid of the square root. We multiply by 1 inside. We see this is 1 plus cosine theta, 1 plus cosine theta, 1 plus cosine theta squared. And we take square root, we get 1 plus cosine theta. Here, 1 minus cosine theta, 1 plus cosine theta, we get 1 squared minus cosine squared theta. That is 1 minus cosine squared theta. That is sine squared theta. So we get this one, sine theta over 1 plus theta. We can do other trick. We multiply this one. 1 minus cosine theta, 1 minus cosine theta. So on the top, I get 1 minus cosine theta. On the bottom, I get 1 minus cosine squared theta, sine squared theta, sine theta. Next, product to sum or difference. Product to sum or difference. I'll take 2 examples for you. For example, I want to find the cosine alpha sine beta. When we recall, this product with different function appears in sine alpha plus beta and sine alpha minus beta. So I write down these 2 formulas. Okay? And we check cosine alpha sine beta. This is one. So we take sine alpha plus beta minus sine alpha minus beta. These terms cancel out. These terms minus minus positive become 2 cosine alpha sine beta equal to sine alpha plus beta minus sine alpha minus beta. You see, it's less than 30 seconds. Another sample, sine alpha sine beta. We recall these products with the same function appears in cosine alpha plus beta and cosine alpha minus beta. So we write down, we check sine alpha sine beta. So we take cosine alpha minus beta minus cosine alpha sine plus beta. And we found that this term cancel out. This term plus minus minus plus, we get 2 equal to cosine alpha minus beta minus cosine alpha plus beta. That's it. Finally, we deduce sum or difference to product formulas. This is sum, this is product. This difference, this product, and cosine, so on. Let's check one. I want to prove this one. We remember that this product with different function appears in sine alpha plus beta, sine alpha minus beta, like this one. And you compare this. This is two angle. This is two angle, sum or difference. And here is one angle. So what I do, I make it into two. How? I set alpha equal to x plus y, 2. Beta equal to x minus y, 2. I put alpha beta inside this one. I get sine alpha, sine beta equal sine x plus y plus sine x minus y. Let me extend these two sum and difference formula. We get, this is 2 sine x sine y. This is not what we want. We want alpha beta. Replace x and y. How? Now we look this way. Alpha plus beta, y minus y cancelled out with a 2x. So alpha plus y equal to 2x, x equal to half alpha plus beta, like this. Alpha minus beta, x cancelled out, y minus y, 2y. So f minus equal to 2y. Y equal to half alpha minus beta, this is y. So we put xy in this one, we get sine x cosine y equal to sine alpha plus beta half. Cosine alpha minus beta half, exactly as before. Sine alpha plus minus sine beta are same thing, we can deduce. Next, we find cosine. For example, cosine alpha cosine beta. We do the same trick. We set alpha equal to xy. Beta equal to x minus y. We put this alpha beta inside. We get sine alpha minus cosine beta equal cosine x plus y minus cosine x minus y. Then we extend these two cosine, we get they equal to minus 2 sine x sine y. We also try to get x and y in terms of alpha beta. Alpha plus beta, y cancelled out, 2x. So x equal to half alpha plus beta. Alpha minus beta, x cancelled out, y minus y, 2y. So alpha minus beta equal to 2y. And y is half alpha minus beta. We put xy in, we get this minus sine half alpha beta. Sine half alpha minus beta. This is exactly like above. That's all deduction. Okay? Last one. In many cases, we have a sine alpha, b cosine theta given. We would like to express them in a single trigonometric function, like sine. That's complicated. I don't remember. What I do, I say, now, you want to write it in a single trigonometric function? Okay, I write it to c sine alpha plus theta. Here, c and theta are two constants to be determined. How do I do? I just express sine alpha plus theta. Sine alpha plus theta equal to sine theta alpha cosine theta plus cosine alpha sine theta. In order to compare with this one, I rewrite this one. C sine alpha cosine theta, I write C cosine theta sine alpha. C cosine alpha sine theta, I write C sine theta cosine alpha. Then if we compare to the top, the coefficient in front of sine alpha should be the same. So we get C cosine theta equal to A. The same thing, C sine theta equal to B. If I rewrite this, cosine theta equal to A over C. Sine theta equal to B over C. We look at these two equations. Two unknown, theta and C. We can easily find theta and C. How? First, I take tangent theta. Tangent theta equal to sine theta over cosine theta. Sine theta equals B over C. Cosine theta equals A over C. We put inside, we can cancel out the C. We get tangent theta equal to B over A. So theta is arctangent B over A. Arctangent B over A, theta. How about C? Let's see this one. Cosine squared theta plus sine squared theta equal to A over C squared plus B over C squared. And this should be 1 because sine squared plus cos squared equal to 1. And from this, I get A squared plus B squared equal to C squared. And C equal to square root A squared plus B. Exact this one. So I put C and theta inside and get this formula. That's all. Let's summarize. How to remember trigonometric formulas. We use sum and difference formula to deduce them. They are sine alpha plus beta equal to sine alpha cosine beta plus cosine alpha sine beta. How to remember that? Sine, same sign. Sine, same, the function is different. Sine, cosine, cosine, sine. And the cosine alpha plus beta is different. How different? Sine is different. And function are the same. Cosine, cosine, sine, sine. As once we know this one, we change the sign. We change this sign to minus. We change this sign to minus. I get sine alpha minus beta. We change this sign to minus. We change this sign to plus. We get cosine alpha minus beta. These 4 identities is the base one I use to deduce other one. That's it. Thank you.